Hi everybody, we are going to see about the properties of normal probability curve. What are the properties of normal probability curve? Okay, so normal, this is the main, we'll see first the main properties of normal probability curve. The first property is the normal curve is symmetrical. Second property is the normal curve is unimodal. The third property is mean median mode coincides. And the fourth property is the maximum ordinate occurs at the center. The fifth property is the normal curve is asymptotic to the x-axis. The very important property is the height of the curve declines symmetrically. So these are few properties we will be explaining, we will see in detail. The normal curve is symmetrical. Look at this normal curve. Okay, the curve, if you see, just go through this curve. The normal curve is symmetrical about the ordinate. Where it is, you see, the ordinate is 0. You are seeing that 0, that line. If you see the one, if you cut, suppose you are cutting this normal curve into 2 equal half. See the left hand side, this curve, this side is very much similar to the right hand side. That is, we can say that if we cut the curve exactly at 0, both the sides will be of the same. So about the ordinate of the center point of the curve, it implies that the size, shape and slope of the curve of one side of the curve is identical to that of the other side. Next we are going to see the normal curve is unimodal. It has single mode only. This straight line what you see right in between that y-axis, that is nothing but the only one mode here. So the normal curve has a bilateral symmetry that we have seen in the previous slide. If you cut into right, okay, in between it has 2 equal half. Okay, that you have seen the previous one, bilateral symmetry. Okay, if you fold it, suppose you are holding this in the x-axis, both will be coincide with each other. That is bilateral symmetry. That is left side is equal to the right side. Or next we are going to see the unimodal. Since there is only one point in the curve which has maximum frequency. Okay, here only one point is there which has the maximum frequency. This one. So normal curve is unimodal. It has only one mode, right? Here, exactly here. So maximum, here is the maximum frequency. Therefore, it is only one mode, right? Next, we are going to see mean median mode coincide. That is, the mean median mode of the normal curve. This point, that arrow mark you can see, both are all this mean equal to median equal to mode. Lie at the 0. Okay, lie at the 0 or baseline. Next one is maximum ordinate occur at the center. Okay, if you see this center, the maximum height, here the arrow mark, you can see it is the maximum height. Here we get the maximum height. The maximum height of the ordinate occurs at the center of the curve. That is at the point, the ordinate at the mean, means this is the arrow mark question, that is the maximum ordinate. The ordinate is nothing but the y-axis. That is nothing but a y-axis. The maximum height y-axis here 0, here the y-axis. Okay, this is known as the maximum ordinate, and it is denoted by y0. Okay, the normal curve is asymptotic to the x-axis. What is asymptote? We'll see. This is a normal curve, right? If you see towards the x-axis, the curve slowly decreases. The curve keeps on decreasing. Can you see this? The curve keeps on decreasing the height. Height keeps on decreases, and slowly it is going towards the x-axis. So the normal curve approaches the horizontal axis asymptotically. Asymptotically means the curve continues to decrease. Height keeps on decreasing on both the sides, but it goes very closer to the x-axis, but it never touches the horizontal axis. That is the x-axis, right? So decreases its height. Okay, from 0 its height is getting decreased, but never touches the horizontal axis. Right? Can you see here it is going closer, but never touches the horizontal axis. Here also towards the right hand side also the height decreases, but never touches the horizontal axis, right? So the curve is asymptotic. So it extends infinitively in both directions. That is, here plus infinitive and here is minus infinitive. So the curve goes from minus infinitive to plus infinitive. Next is the height of the curve declines symmetrically. Can you see here mu, x minus mu left hand side, and mu is the mean, mu minus sigma, 1 sigma distance in the left hand side, and also mu plus sigma, 1 sigma distance in the right hand side. See that exactly at this height, if you see mu minus sigma, the height, that is y coordinate, is same height, mu plus sigma. So in the mu minus sigma, the height of the normal curve, that is that straight line you have seen, that is same as the height at mu plus sigma. So the curve, if you see, it decreases, the height of the curve declines symmetrically. So in the equal distance, if you say equal distance, the height is same. That is what we want to say. Equal distance from mu, the height is same. That is what exactly it means. See, the height is same. So equal distance, the height is same. The point of influx occurs at plus or minus 1 sigma. We'll see the next one. The point of influx occurs at plus or minus 1 sigma. If you see the curve here, normal curve, see, plus this is these two lines. This is 1 sigma distance. See, minus 1 sigma in the left hand side, plus 1 sigma in the right hand side. So 1 sigma distance in the left hand side and right hand side. The convex. The curve was convex. Can you see here? The curve is convex, right? If you go after 1 sigma, the curve, the shape changes to concave. Can you see this? It's a concave. So this is known as point of influx. Exactly occurs as plus or minus 1 sigma, right? This is known as point of influx. Here also, convex, it turns to concave. That is point of influx. This is the point of influx. So point of influx occurs at plus or minus 1 sigma. The curve shape changes from convex to concave. And the total percentage of area lies within 2 points. Between this influx only, total percentage area lies. That is 68.26%. The left hand side, if you see from that straight line, that is from the mean median mode, no, where it coincides, this line. This straight line where it is maximum, okay, where it is maximum. From this line, if you see, from this line to minus 1 sigma, the area covered is 34.13%. Okay, same way, from the maximum height to minus 1 sigma, the area covered is 34.13%. So the total area is 68.23% between minus 1 sigma and plus 1 sigma. This is what, right? Normal curve is a smooth curve. It is not a, how to say, histogram or something. It is a smooth curve, right? The normal curve is bilateral. Bilateral means the two half coincides, the symmetrical both the side. 50% of the area lies in the left hand side, this left hand side, 50% area lies in the right hand side. That is known as the bilateral. Bilateral symmetrical, we can say. The normal curve is a mathematical model in behavioral sciences. If you see psychology and all, this normal curve is highly useful and it is used as a mathematical model in behavioral sciences. Next is the percentage of cases falling between the successive standard deviation in normal distribution. If you see the normal distribution, okay, you see percentage of area lies between this. Plus 1 sigma minus 1 sigma. So if you see plus 1 sigma and minus 1 sigma distance, the area covered is 34.13% in the left hand side and 34.13% in the right hand side. This is the mean. 1 sigma minus 1 sigma distance in left hand side plus 1 sigma in the right hand side. The total area covered between minus 1 sigma and plus 1 sigma is 68.26%. If you see minus 2 sigma, that is from minus 1 sigma to minus 2 sigma, the area covered is 13.59%. And same way, minus 1 sigma to, plus 1 sigma to plus 2 sigma, the area covered is 13.59%. see minus 2 sigma. That is minus 1 sigma to minus 2 sigma. The area covered is 13.59%. Plus 1 sigma to plus 2 sigma. The area covered is 13.59%. What is the area covered we are seeing, right? And then we are going to see minus 3 sigma. Okay, the distance between minus 3 sigma. That is distance the minus 2 sigma to minus 3 sigma. The area covered is 2.14%. Same way, plus 3 sigma, the area covered between plus 2 sigma and plus 3 sigma is 2.14%. The total area covered between minus 2 sigma to plus 2 sigma, minus 2 sigma to plus 2 sigma. The area covered in this region is 95.44%. The area covered between minus 3 sigma to plus 3 sigma is nothing but 99.73%. And the tail area, that is which we have not covered here, that is 0.14% here, and here also 0.14%. Here you can insert minus infinitive in this side and plus infinitive in this side, right? Equation of normal curve, y equal to n divided by sigma root 2 pi e power minus x minus mu the whole square by 2 sigma square. What is y? Y is nothing but the height of the curve above the x-axis. That is nothing but frequency of the given x value. X is nothing but x score, that is observed value, right? What is mu? The mean of the distribution. N is nothing but number of cases. So if you are having how many cases, how many people suffered or something like that, this is the number of cases. Just like n number of trials in the binomial distribution, right? Sigma is nothing but standard deviation of the distribution. Pi is nothing but 3.14 and E is nothing but 2.713. What is the beauty here? That is, if you see normal binomial distribution, which is a discrete distribution, that is nothing but the limiting case of Poisson distribution. Binomial means if n turns to infinity, you are getting the Poisson distribution. So Poisson distribution is nothing but the limiting case of binomial distribution under certain conditions, right? When n turns to infinitive and p turns to 0 and p is very close to 0. So in that case, binomial distribution is nothing but the limiting case of the Poisson distribution is nothing but a limiting case of binomial distribution. Both are discrete distributions. Now we are going to see the normal distribution. Normal distribution is nothing but a limiting case of Poisson distribution under certain conditions. Therefore, in general, we can say all distributions, the binomial distribution is the, from binomial distribution we can go to the normal distribution, where normal distribution is nothing but continuous distribution, but it is a limiting case. Actually, all distributions will be turning to by normal distribution under certain conditions. That is a speciality of the normal distributions. That is, any distribution, let it be discrete or continuous, and under certain conditions they are converging to the normal distribution. Therefore, normal probability curve plays very important role in statistics.